Hi, grade 12 students. Our study today is to find the derivative of composite function. What concerns us at the end is this formula written here at the end. This is what concerns us. This is what we need to memorize. But I want to prove how we got that property. So we want to find the derivative of composite function. We all know we took the composite function in grade 10, f of g of x. Instead of writing g of x, I want to name g of x by u. So we have f of g of x, which is f of u, where u is a function of x. Why u is a function of x? Because u is an expression of g of x, and g of x is in terms of x. So our aim is to find the derivative f of u prime. Let me introduce the u in derivative dy over dx. We can write dy over du times du over dx. It is the same as dy over dx because I can get rid of du and du. You're left again with dy over dx. But what does it mean dy over du? Dy over du, you all know y is f. So dy over du, it's f prime of the variable u. And du over dx is u prime of the variable x. But u is g of x. U is a g of x, we name it up, and u prime is g prime of x. So the properties say, if you want to find the derivative of f rho g of x, which is f of gx all prime, you do the derivative of the function inside g of x, and you write it outside times derivative of g of x in f prime of g of x times f prime of g of x. Here, g of x, you don't change it. You don't put a prime. So I'm going to repeat. If you have f of g of x, you want to do the derivative. We do the derivative of inner function g of x, and we write it outside as g prime of x. Then we do f prime of g of x. So let us take some examples. Given f of x 2x squared minus 1 and g of x is sine x, we want to find the derivative of f rho g of x and g rho f of x. Let us start first of all by finding the derivative of f and g. Derivative of f is 4x, derivative of g is cosine x. Now we want to find derivative of f rho g, which can be written as f of g. So as I said before, I take this g here, I write it as derivative outside the inner function. Then I put f prime here and I keep g of x as it is. G prime of x, we did it already, it's cosine x, we write it here. F prime of g of x. G of x is this one, we write it here. F prime of g of x. Composite function, grade 10, remember, what's f prime of sine x? I go to the function f prime. F prime is 4x, but I want f prime of sine x, so I replace this sine x instead of x. So I get 4 into, I replace this sine x in f prime, so I get 4 sine x. So this is the answer. If I want to do the vice versa, as I said, I do the derivative of the function inside f prime times g prime of f of x. F prime of x, we already did it, it's 4x. G prime of f of x. F of x is 2x squared minus 1. Now I go to function g prime, which is cosine x. I replace this x by 2x squared minus 1. So I get 4x into cosine 2x squared minus 1. Another example, same story. First of all, I do the derivative of x cubed 3x squared. I do the derivative of this one, u prime of v minus v prime u over v squared. Derivative of x is 1 times cosine x minus derivative of cosine is minus sine, so minus and minus plus times x over denominator square. So I want to do f g of x prime. As I said, I take g of x, I do its derivative times f prime of g of x. I keep g of x as it is. G prime, we did it, is this whole expression. I write it here. And f prime of g of x, this is g of x. So I go to f prime, I replace this x here by x over cosine x. So I get 3 into x over cosine x and I square it. And vice versa, g f of x is f derivative. It's f prime of x, derivative of inside, times g prime of f of x. F prime of x, we have it 3x squared. G prime of f of x, this is f of x, x cubed. I go to g prime now, this is g prime. I replace every x here by x cubed. x cube, x cube, x cube, x cube. So I get this one. Let us take another example here. It's another way of asking the question. You want to find the derivative of this whole expression. This expression is also fg of x. So let us say, in other words, let us say g of x is 3x squared minus 2x minus 1, and this is f of x. Let us do g prime. Derivative is 6x minus 2. Derivative of tangent is secant squared. So let us start. So as we said before, this is g of x. I take it outside and do its derivative. Look here, it's a prime times f prime and keep inside. Derivative here, as we said, it is 6x minus 2. Here I go to f prime. I have f prime is secant square x. So I replace this whole expression by x. So I get secant square of 3x squared minus 2x minus 1. 4, same story. I want to do the derivative of f3 radical x. So I name this by g of x. Here I do derivative of g of x, which is 3 over 2 radical x. I do the derivative of f of x, which is 4x. So I take this outside and do its derivative. I have it already, which is 3 over 2 radical x. And I go to f prime. This is f prime. I replace this x by 3 radical x. I get 12 radical x. The last example. Suppose I gave you a table. This table, then it means f of 0 is 1. For example, f prime of 0 is 5. G prime of 1 is minus 8 over 3. I gave you derivatives of f prime and g prime at the point 0, 1, as well as their value f and g at 0 and 1. I want to find the derivative of this one. So let me start by the first one, derivative of that one at x equal to 1. So I want to do the derivative here. I copy it again. So it's 5f prime of x minus g prime of x. I want it at x equal to 1. They told me to find at x equal to 1. So I replace x by 1. 5f prime of 1 minus g prime of 1. And f prime of 1, this is f prime of 1 minus 1 over 3. G prime of 1 is minus 8 over 3. So just I replace. This of the form u over v. U prime f prime times v minus derivative down g prime x plus 2 into f of x over denominator square. I want it also at x equal to 1. So f prime of 1 here is minus 1 over 3. G of 1 is minus 4. X is 1, so plus 2 minus 1. G prime of 1 is minus 8 over 3. F of 1 here is 3, as you can see, over g of 1, because all at x equal to 1 is minus 4, and x is 1 square. Let us take the other. Here it's composite function. The derivative of fg, as we said, g primes into f prime of g of x. They wanted at x equal to 0. So it is g prime of 0 times f prime g of 0. G prime of 0 is 1 over 3. G of 0 is 1. So I have, instead of writing f prime of g of 0, so I write f prime of 1. And f prime of 1 is minus 1 over 3. So I got minus, I will get minus 1 over 9. Coming the same but inverse composite, just the opposite, g f of x. So as we said, it's f prime times g prime of f of x. They want it at x is 0. So f prime of 0 times g prime f of 0. F prime of 0, guys, it's 5. G prime f of 0. F of 0 is 1. So I do g prime of 1. It's minus 8 over 3. Here come in derivative of composite f of x plus g of x. I do the derivative of inside. 1 derivative of x is 1 plus g primes plus f prime, and I write this again at x is 0. I replace x by 0, as you can see here, here, and here. G prime of 0 is 1 over 3. And g of 0 is 1. So I have f prime of 1, and f prime of 1 is minus 1 over 3. Thank you for, hope you understood the derivative of composite function, and see you on Monday in class. I will assign the homework by email. Thank you.